Hi, I just picked this up on eBay. It's one of these little universal programmers. I got it for like 55 bucks Australian delivered, and it came with a whole bunch of adapters and stuff. So I thought I'd just do a little quick video, just overview of just trying to install and use it for the first time. And yes, of course, we'll take it apart. So this is the MiniPro TL866, and it's from a company called AutoElectric.cn, Chinese company, which seems to be specifically designed for like the automotive EEPROM flashing market, you know, that kind of thing where you enhance your car by reflashing the EEPROM and stuff like that. But you know, it's a regular, like, little very compact universal programmer that, you know, they claim supports you know, like 13,000 parts or something like that. It does support PICs and Atmels and serial EEPROMs and flashes and old style EEPROMs and all that sort of jazz. So anyway, for the price, absolutely amazing. And here's the box it comes in. It's rather professional. I like it. It's not like it, you know, a lot of stuff from eBay Chinese sellers. You just get it wrapped in a bit of bubble wrap and thrown in an envelope. It rather instills a bit of confidence. It's designed for Windows 7, and there's two different models apparently. I've got this one, the TL866CS, and I believe the TL866A, I didn't realize this until I actually got it, but the it looks like the A version actually has the in-circuit serial programming port as well on it. So mine doesn't have that, so I don't know whether or not it's just a connector inside or something like that. I guess we'll find out when we open the thing. And for an extra couple of bucks, for like less than 10 bucks extra, I got these little adapters here. Fantastic. Why not? I thought, for the price. We've got a couple of PLCC packages here, 44 and a 20 and a 32, and we've got a couple of these little adapter boards for soldering chips directly on if you have to, you know, if you're desperate and you really need to wire it up, you don't have a ZIF socket or whatever, no worries, just solder it directly onto those. And it came with a couple of two different width SO8 packages with the ZIF socket, the proper ZIF socket on it. I mean, you know, you wouldn't use this, I'm sure they're not the greatest quality, you wouldn't use them for production programming or anything like that, but gee, you know, for yeah, I think less than 10 bucks included all those adapters. So I thought, why not? And the unit itself, it comes with a 40 pin, supposedly it is branded 3M, but if that's a genuine 3M text tool socket, then I'm a monkey's uncle. But anyway, good enough for one of these low quality programmers. It feels pretty good. So let's crack it open, have a look inside, and after we do that, then we'll hook up the software and give it a whirl. 4 screws on the bottom there. I do actually know what it looks like inside because the seller actually proudly showed off the internal circuitry, and it looked quite compact and quite high quality. So here it is. Bang, we've got 2 board construction there. Some standard SO packages on there. We'll take a look at the parts in a minute. Standard SOT23s along here, and some protection diodes as well. The LEDs sticking up through the top of the board there. And it looks like the boards are stacked together using dual way standard 0.1 inch headers there. There's actually 3 of those by the looks of it down in there, and that looks rather quite nice. I mean, at first glance, the soldering looks pretty good. Let's have a look on the bottom here. Aha! Of course, they've shaved the number off, as they do. We might be able to put a bit of spit on that later and try and reveal what that is. But lovely, you know, array of protection diodes down in here. Or they protection Zenas or something. Anyway, it looks like we've got double-sided load on both of these, and the soldering actually looks really quite nice. I'm quite impressed by this, especially for the price. I mean, you know, but you can get this under $50 delivered if you don't get the adapters, like $45 delivered or something. Anyway, it looks like we've got some huge inductors here for the DC to DC supply. They look really quite nice. I can't separate those because I'll have to desolder that, so no, it's not a problem. Okay, that was a little bit annoying. I had to desolder the two LEDs out of there as well, just pull them out and desolder them from the bottom, and was able to sort of use my third hand to crack this board to separate the boards while desoldering those two pins, and ta-da! And there you go, there's all the switch-in transistors. They would be MOSFETs, I'd be assuming, for each pin. I mean, this is certainly not a, you know, it's not like a DAC per pin universal programmer or anything like that, but it's going to be good enough. It's going to have a reasonable amount of flexibility, and we should be able to check that in the software perhaps. And that unpopulated J1 connector down there, obviously the in-circuit programming / JTAG port for our chip here, which has had the number rubbed off, the bastards. But we'll get a bit of spit on that in a sec. Zingong, 4th month 2012. But I really like the construction of this thing, no problems at all. And of course, if you have a look down here, we've got the connector for the in-circuit serial programming. So I'm assuming that you can just I a connector onto that, so I might do that, and maybe, I don't know if I'll test the in-circuit programming capability today, but I assume that that's the only difference, is that the actual connector is populated, because I don't see any other missing parts on here, unless there's like a firmware difference between the two or something like that. So it's time for a bit of spit, so let me get some magic spit on there. And no, they've done a cracking job there, I think. They've done a really good job on that one. I don't know, I'm probably, you know, going to assume maybe it's a little ARM processor or something like that that we saw in a Universal Programmer teardown a month or two back. But yeah, I don't know. You could reverse engineer that, of course, without too much difficulty, but I won't bother. And all of the drivers on the top of the board here, 74HC 373, so octal latches, so they're driving those with a single parallel bus and then latching the individual lines for each of those. And there's another 2 of those on the bottom here as well, and they've got a 74HC 164 there. Got a voltage regulator down there. That's a, no surprise, a 1117 low dropout reg. And up here we've got there you go, a Motorola 34063, absolute classic. That's how they've got the cost down on this thing. They've, yep, there's 2 of those, 34063 DC to DC converters. So, you know, pretty cheap. So it's not surprising that they can get the cost down on these things, because there's not, you know, I mean, there's a huge amount of transistors and diodes and stuff in there, but, you know, they're pretty darn cheap. Apart from that, we've got, you know, some HC series logic, some cheap as chips DC to DC converters, and the main micro, and that's it. And the ZIF socket, of course. But what it's all about with these universal programmers is the software. So I've whacked in the little disk here, and we've got MiniPro V580 setup. I don't know what that CHM file is, so let's run the setup program and give it a burl. Come on. There we go. Welcome to use MiniPro TL866 programmer D/MiniPro. Ah, yeah, well, install. Bam. Oh, lots of AppMail files I saw there. Driver. Yeah, we'll install a driver as well. Not a problem. Install device USB driver. MiniPro USB driver. Yep. We'll install that. I think we're going to get a lot of Chinglish with this one, folks. I would expect a lot of Chinglish. Install. Would you like to install it? Always trust. And I won't always trust, but yeah, I'll trust it this time. Let's go. And that only took a minute, and we're ready to use. So let's call it up, MiniPro programmer. Bang, we're in. Check it out. There it is. Beautiful. Works a treat. Hasn't detected, of course, because I haven't plugged it in. So let me do that. And Give it a go, see if it detects. Yeah, it detected. It's installing the software. Please reflash Fireware. There we go. We got some great Chinglish there. I love it. Please reflash firmware. Obviously, why it's telling us to reflash the firmware, I don't know. But yeah, it's telling us how to do that. We have to go up into what, tools. Yeah, there we go. Reflash firmware. There we go. They've got it correct there. But it certainly automatically detected it. There it is. Hardware interface. TL866CS. So it's the CS, not the A version. Version 3.255. So let's run that system self-check I saw up here, and please remove IC on 40-pin socket. No worries. Test. Oh, bang. Successful. Hey, look at this. Here we go. Hey, this, there you go. This is going to tell us how many channels it's actually got. There we go. There's the VPP programming voltage, and that looks like it's switchable. Not through all 40 pins, of course, but it's switchable through 16 different pins. That means when they designed this universal programmer, they obviously looked at the variations of the pin outs of the various chips available that they wanted to support, and determined, well, we need 16 different pins for the VPP, the programmable VPP programming voltage. So there you go. And they've done a similar thing here with VCC, I'm assuming. How many channels? So with the VCC, there we go, 24. So you can switch the main chip power through to 24 different pins. I'm assuming, and ground, they would have done a similar thing. So it's not a true universal programmer. There you go, 25 pins for switching ground through. And hey, it looks like it does overcurrent protection testing, and on the VPP and the VCC. That's really neat. I'm assuming that it has a transistor and it shorts out the rail and determines that the current limit is working. Neat. I like that. Beautiful. All right. Oh, I could test that all day. All right, so let's have a look at the rest of the programmer here. They've got language up the top. There we go. You can switch between Chinese and Chinglish. It's not. I think we're going to get a bit more Chinglish in here before the video is out, but it's got all the basic stuff. It's got the edit window. Can we edit that? EE? No. Oh yeah, there we go. Yep, tells us it's red, not a problem. So, great. That works a treat. Okay, so we can edit the edit window and data memo, buff select, code memo, data memo, and the config fuses. There we go. There's all the config fuses for, what have we got? We've got, by default, they've selected a PIC 18F4550. So that looks like it's doing the business there. I like that. All your configuration bits. So you can go in and individually set all your configuration bits. Let's try, say, an Atmel one. Let's choose how do we choose an read ID calculator? Just calls up Windows calculator, that's it. Select IC, there we go. Search and select, or you can do, looks like you can do flash detect. Auto flash detection. There you go. So if you've got a flash memory device, 8 or 16 pin, you can whack that in there and have it auto detect. Okay, that's neat. But we'll search and select. Let's look at the devices that are supported here. You can select between all ROM, flash, non-volatile RAM. They're all your manufacturers, lots of them. I mean, a lot of them are going to use identical algorithms and stuff like that. But MCU, MPU, there we go, Atmel. The Atmel support is the 1898, 8089 series, 1890, and it looks like a pretty comprehensive list of all the AT megas and AT tinies, and that's where it ends. So let's look at microchip. Here we go. It does so 10, 12, 16 and 18 series PICs, but that's pretty neat. PLD, GAL, CPLD, Atmel, one device, Lattice. Yeah, it's got a few Lattice devices in there, but nothing much. SRAM, SDRAM, neat. But of course, most of the time you're going to use this with EEPROMs, old EEPROMs or E2 proms or something like that, usually. So it supports all the usual culprits. That's quite neat. So what I wanted to do there is just go into Atmel and just look at the configuration fuses. So let's choose a, an ATmega 168 or something. So let's select that, and there's the code memory, data memory, and config. There you go. Nice. It all seems to be there. Whether or not you would trust one of these $50 programmers, it's probably good enough, but you'd expect the odd bug perhaps or something like that. It's not as good as the vendor tools, of course. And if you have a look around here, there's the Icsp port. So if we click on that, using Icsp interface program, make sure, power supports 128 milliamps maximum. So it looks like you can select, so it can generate a voltage on the Icsp port, I'm assuming, to power your particular product. So yeah, it's actually allowing me to do that. So VCC enable, you can turn the voltage off and on there. So I'm assuming it will allow us, if we solder on that connector, we can probably do in-circuit serial programming as well. Now I've plugged in a real 40-pin PIC chip here. I've got a PIC 16F877 in a 40-pin DIP package, and I've selected that there, 16F877. It was certainly in the library, and let's see if we can... I don't know if this one's actually programmed with anything or not, but let's look at the configuration fuses. Can we read the configuration fuses at all? Let's have a look. We can program it up here. We can erase it. So we can read from the chip. We can fill it. We can verify. So it's doing all the usual stuff. Blank check, read ID. So yeah, there we go. I just read the ID there, and it got chip ID 04D Rev 03. I'm assuming that is the correct one. I'd have to look up the microchip information to actually verify that, but it certainly read it. And if I disconnect it, let me pull the chip out. Let's read the ID again. Nah, it's reading 0. So if I whack it back in and boom, put the ZIF socket down. Yep. So it's reading that PIC chip. Not a problem at all. So let's read it all in. Read from chip. Please reflash the firmware. Bummer. I wonder why out of the box it's making me reflash the firmware. So it looks like we can't really do anything. We probably can't program it either until we reflash that firmware, I'm assuming. Oh, serial number. Here we go. There we go. Auto serial number. There we go. We can do auto serial number. It does have that feature that I was talking about before. So brilliant. Random serial number, time mode, default, excellent. Great stuff. Okay. Now, let's reflash the firmware, shall we? I'll disconnect my PIC chip just in case, and here we go. Fingers crossed, reflash firmware. Attention, please carry on this upgrade operation on the computer reliably. Guaranteed the computer's power supply, blah, 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 blah. It's the TL866CS. Current firmware is 3.258. Click reflash to upgrade. Doesn't tell us which version we're upgrading to, but, well, here we go. Reflashing firmware. Elapsed time erasing. Okay, hope it doesn't brick it. If it bricks it, I won't be happy. I've done my $50. Reflashing the firmware. Successful. Neat. Okay, well, let's see if we can read our chip this time. Put my PIC back in. Read ID. Yep. Working a treat. Let's read the chip. Here we go. There we go. It's telling us to put it in. And make sure you get code memory, data memory, config fuse, user ID, and read. Boom. Done. That was quick. And it read it all in. Not a problem. I've got nothing useful to program into this, but we can just test that it verifies and stuff like that. So let's go up to verify here and verify, because it read in all of the config fuse stuff and things like that. So, yep, bang, it verified. Now let's actually test that and go in here and modify. Say, let's disable brownout detection there. So let's disable that. And right, so I've disabled that. Now it should not verify. It should tell us that there's an error. There you go. Bang. Got it. Memory error. Config. Yep. Continue. Marked. Don't know what marked is. It works. That's a bit of a sanity check. Not a problem. It's got all you know, all the functionality you expect of a good universal programming software. I like it. So let's program this PIC chip, and we've turned off the brown out there, and programming elapsed time, blah blah blah. It's taken its time. I can't remember offhand what size this 18F877 is, like 8K or something, 16K. It's taken a bit of time, but apparently this advertises itself as being fast, and you can go to the there's a chart on the eBay sellers page, and they had like, oh, it can do a 4 meg flash chip in, you know, 10 seconds and stuff like that. So apparently, you know, it does actually promote itself as being reasonably quick. So, but for a one-off, you know, you're not going to use this thing as a production programmer, really. I mean, you know, if you're doing critical production stuff, you wouldn't be using a $50 programmer, but, you know, so its speed isn't that important for just one-off stuff, which most people will use it for. But yeah, no problem. Program that just fine and dandy. Now, there's one interesting thing I've noticed here. When I'm switching through all these ROM flash stuff, I don't notice any 256K variants. They're all 128 or 512. And it just so happens that I do have an Atmel AT27C 128 in DIP28 package. So I've got that in the socket there. It's exactly the same. It's really old. It's like 1988 vintage. But I whack that in there, and let's read. Boom. Yes, we actually got it. Okay, there we go. It read that, no problems at all. So, and here we go. It's staring me in the face. Check device ID. There it is. So you can just disable that. So not a problem. If you've got an unsupported chip and you know it's the same pin out and the same type and everything like that, just disable that and you shouldn't have any problems. So verify after. There we go. And I've read in the data, and I do remember kind of writing a sequence of data in there. This was many, many years ago when I used to sell EEPROM programming software. Way back, when I had my own little software business, and yeah, it's I believe that's the data. It's still in there. I would have programmed that in 93 or something like that, perhaps. But it's a 1988 vintage chip anyway. What I'm going to do is I'm going to fill this sucker with let's fill it with just random data. Shower value fx random. Here we go. Let's just fill the whole thing with random data. There we go. I'm going to see if I can program a 1988 vintage Atmel AT27C 128. So let's give it a go. I like that. Check this out. You can actually change the VPP voltages. It looks like you can't enter them, but you can select different ones at least. So you can at least do some margin testing there. VCC verify. There you go. You can test it at lower margins, lower voltage margins if you want. That's really quite nice. Pulse delay. Okay, you've got a little bit of control over there, over your programming information. That's pretty good. Anyway, I want to program this sucker. Here we go. Programming chip. Are we ready? You bet. Oh no, of course it's not erased. Need an EEPROM array. This is a freaking EEPROM. But here we go. I do have a blank AMD 27C 128. So I've got that selected in there, and I've already read it. It is actually blank. Read. There we go. So it looks like it's blank. Well, I could do a blank check. Here we go. Where's the blank check option? Blank check. There we go. Blank. No. Hang on. Device ID check. It doesn't really like that at all. Blank check. I don't know. It's the exact type, but it is empty. There you go. So I'm going to try and program that sucker. So we'll fill it with random gunk again and give it a go. I don't know. This is there's no date code on that one. So that's interesting. Let's pop it over. And 9011. There you go. So 1990 vintage. Let's put it back in and let's give it a go. Here we go. Program. And fingers crossed, don't do the device ID check. Bugger that off. But will it program? Overcurrent protection action. No external short circuit, IC reverse, or damaged. No, something's going on there, folks. Wah, 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 wah. But of course, I just noticed that this has 12.5 volt programming voltage written on it, and by selecting that device in the library, it had 13.5 volts. So VDD, right? No, let's whack that to 5. I don't like that. Let's leave it at 5. 5 and 5 for verify and write, and 12.5 volt for the programming voltage. Let's give that a go. Pulse delay. Let's up the pulse delay. I don't know. Let's double it. 200 microseconds. It's not going to hurt. So let's program that again. Do a blank check. Make sure it's blank. Yep, it's still blank. Now let's program. Programming stop. No overcurrent protection again. Fail. Now I've actually got a National Semiconductor 27C16 here, and as I noted before, there were no 256 options, but there are also no 27C 16 options either. Like, it's, you know, regardless of the manufacturer you choose, it looks like it has 128K and 512. That is, you know, that's ridiculously limiting. I don't like that at all. And, you know, you've got, I mean, it's expecting now to see a 28 pin device in there, and it's not. Crazy. So if it can't support 24 pin EEPROMs, I mean, they're all 28 pin. Let's go through them. They're all DIP 28, DIP 28. It only supports EEPROMs that are 28 pin and 32 pin. Are you kidding me? Alright folks, here we go. Hold on to your hats. I found the device support list. There's the URL, and it does support all of those devices which I was trying to do. Let's go to AMD, for example. Look, 2716B. There's the 25. Yeah, there's a H256. But it's look at all these different devices which weren't in my included software. So I'm not sure if, yeah, look, TSOP 44, TSOP DIP 24, look, all these different packages. So there's a hell of a lot more devices this thing supposedly supports than what came in the software. I'm going to have to investigate this, see if there's some sort of update or something I can get. Yeah, here you go, folks. I just downloaded and installed the latest software. Same version 5.80 that I was using before, I believe, but it seems to have all the device support in it. So I don't know why the included CD didn't have it. But look, if we go into ROM, Flash, AMD, boom, here it is. Look, there's the 2716 I had before and the DIP 24 that I couldn't get. And heaps more than we had before. Brilliant. And now if I plug my 1989 vintage National Semiconductor, it's got the exact type, the NMC 27C16Q. And yeah, I've got the Q version, so it's even got that in there. Fantastic. So I can read that. Yeah, bang. Let's read. Oh, there we go. FFFFF. It's all blank. Still blank check. Yep, it's blank. So let's fill this sucker up. See if we can program this one. May or may not be able to. 21 volts. These are the old 21 volts programming voltage. So it supports these. Fantastic. I like it. Here we go. Fingers crossed. Program. Yes! It's doing it. It's doing it. Ripper. A 1989 vintage EEPROM. Oh, I assume it's going to work. Oh, there you go. Beautiful. We just programmed a 24-year-old 21 volt ancient EEPROM. Brilliant. And let's verify that. Verify. There it is. Yep, verify finished. No problems at all. And we can read that back in. Read finished. Fantastic. I love it. There you go. Absolutely spot on. So there you have it. There's the Auto Electric MiniPro TL866 CS programmer that you can get for under $50 on eBay, and it's not bad at all. A few little niggling issues, but it seems to have quite wide device support, and the hardware is pretty decent quality, and the software does pretty much everything you'd expect. Yeah, you could do a lot more testing, but this just covers the basics. It does seem to work. So I think that's pretty much a winner in the low price. And there you go, 258 yuan. Woohoo! You can get a Barbara, do powerful, software smooth, easy to use, cheap, generic programming. Fantastic. And you can see that inside, their inductors are a little bit different to what we had on ours. There you go. But anyway, I think not a bad quality little program. Amazing what you can get for $50 these days. And ultra low power consumption, portable super performance, best over voltage over current protection, so it protects your devices and the programmer. And you can get it with all the those little adapters thrown in for next to NICs as well. So that's pretty impressive, and it seems like a pretty quick programmer as well. So anyway, worth having in your toolbox at that sort of price, just in case you need to read an old EEPROM or a serial EEPROM, or hack around with products or do something like that, or even for PIC or Atmel programming. Worth a look. So anyway, if you want to discuss it, jump on over to the EEVblog forum, and I hope you enjoyed it. Catch you next time.